Hi everybody! In this video we're going to talk about limits again. However, this time we're going to talk about limits that approach infinity, positive infinity and negative infinity. So, first of all, what does it mean to have a limit? For example, if your parents said you have no limit at all, you go on a shopping spree. What does that mean? Whereas if they said, all right, here's your budget, this is your limit, this is all you get to spend, which one would you rather have? So, if we understand it in an everyday situation, what it means to have a limit is it means this is your number, you cannot go over it. This is absolutely not crossable. How is it possible to talk about limits involving infinity? Well, when we talk about a limit having the value of infinity, what we're doing is we're saying the limit does not exist, actually. If a limit goes to infinity, there is no limit. However, what we're going to try and do is we're going to try and use the notation of saying the answer is infinity to indicate how the limit does not exist. Remember, we talked about an oscillating function. An oscillating function goes back and forth between two values. It doesn't approach one single value, but it also doesn't go to infinity. So when we say if limit approaches infinity, we're saying literally the function values are getting bigger and bigger and bigger, and they don't stop getting bigger. So that's what we're going to look at here. How do we recognize this graphically? So the first one that we're going to look at here in part A is the limit as x approaches -2. Remember what this little minus sign up here means? From the left. All right, so first of all, let's go to our picture and look for where x is -2. All right, x is -2 is actually this vertical line here. Does anybody remember what this means, this notation of a dotted vertical line in a graph where the curve appears to be approaching it? Remember, this is called an asymptote, specifically a vertical asymptote. So we want to approach this vertical asymptote from the left. So where do we get on the curve? I want you to think about it. Take a moment, pause. If you want to try some of these on your own and come back and watch the video, that'd be great. See if you have an idea of what this is before I tell you. All right, so here's what we're going to do. To the left of the asymptote, I'm going to get on my curve. So x marks the spot. I'm going to follow the curve towards my asymptote. Where's my curve going? It's going down. Remember, when you approach a vertical asymptote, you get closer and closer and closer, but you never actually get to the asymptote, which is fine when we talk about a limit. A limit doesn't care about you actually getting to your goal. It says what happens as you get closer and closer and closer to it. So what is this function value doing, meaning what are the y values doing, as we follow this curve down towards our vertical asymptote? The function values are getting more and more negative. So we would say that this function is approaching negative infinity as x approaches -2. And that would be your answer. Now, is that a limit? Absolutely not. This means you can go as in debt as you want if you want to think about negative numbers. Now, that's not realistic, except for maybe the U.S. government. Whole new story. But you can go down to negative infinity means you just keep going more and more negative and never stopping in that direction. That's what this is happening here to this function. So we haven't found an actual limit. We're describing how the limit doesn't actually exist. All right, let's try another one. So here we are approaching 1, positive 1. Again, we have the little minus sign. Remember, this minus sign in the exponent means the direction. So from, again, the left. So where is positive 1 for the x? Oh, okay, that's going to be this line here. What is happening at x equals 1? Another vertical asymptote. You'll find I use VA for vertical asymptote a lot. So we're trying to approach this vertical asymptote at x equals 1, but from the left. So let's get on the curve to the left of our vertical asymptote and go towards it. Where is our function value going? Well, the curve is getting closer and closer and closer to the vertical asymptote, but never going to touch it. But as it gets closer, it continues to go up and up and up with no limit. So what's the function value doing? The function is going up and up and up, more and more positive. So we are getting bigger and bigger numbers, so we would refer to those as positive infinity. If you don't want to put the plus sign, that's fine. Infinity would be fine. However, if you don't put the negative sign, and you were supposed to, like in part A here, that would be wrong. You have to put the negative, but the positive is up to you. I'm just trying to make sure you see what's happening. Well, what if we had to approach that same vertical asymptote, this time with a little plus sign from the right? What would that do to our limit? Is it going to be the same answer? Well, let's try. So to the right of the vertical asymptote, we're going to follow our curve, and where is our curve going? It's approaching the vertical asymptote, but in the downward direction. So in this case, again, what are we approaching? Not a limit. We're approaching negative numbers, bigger and bigger and bigger, so negative infinity. So let's put those together. If we have from the left positive infinity, from the right negative infinity, can we say anything about the general limit? We can't put it together and make one nice clear statement. If they had been the same answer, we could write the answer for the general limit and say in both directions it's positive infinity is why it doesn't exist. But because they have two different signs, we would simply write it does not exist for the general limit. If they were both positive infinity, you would write positive infinity. If they were both negative infinity, you'd write negative infinity. But in this case, they're different, so it does not exist. So hopefully that helped you with approaching vertical asymptotes. Now, these last two here are actually a little bit interesting for us because what's happening here? We're letting x approach negative infinity. Where is that on the graph? Remember, x is the horizontal axis. So where would we have to go along the horizontal axis, along the x-axis, to let x go to negative infinity? Which direction? The negative direction. So we would have to go further and further to the left here. So this would be the negative infinity direction. So that's what we're going to do. We're going to follow our curve in that direction and see what our curve actually does. So let me clean this up here. All right, so if we get on our curve and we want to go left, well, this is the furthest point to the left. Let's keep going. What is our curve doing as we go out in this direction? You have to understand what this dotted line is. This dotted line is a horizontal asymptote. So as our curve goes to the left, it appears to be approaching that line, that horizontal asymptote there. Okay. Now the definition of a horizontal asymptote, it is that it dictates what the ends of our curve do. So as we go to the left and as we go to the right, the horizontal asymptote is what our curve has to approach. So the further to the left we go, this curve appears to be approaching this line here. Well, if we're approaching that line, that's going to be our limit. So what is this value of this line? Remember, when you give a limit, it's always the y value. This line is at y equals -2. So that would be our limit as x approaches negative infinity. Hopefully that helps you. If not, let's try one more. Let's let x approach positive infinity. Well, if negative infinity is to the left, positive infinity must be to the right. So we're going to go out to the right, and we're going to let x go to positive infinity. So I'm going to get on the furthest to my right my curve goes, and I'm going to follow the curve in that direction. Notice again, this curve is approaching this dotted horizontal line. Again, we're approaching the horizontal asymptote at y equals -2. So that is going to be our limit. That y value that we're approaching is -2. There you go. Now, notice both ends approach the same horizontal asymptote. Does that always have to be true? Not really. Technically, your two ends can approach two different horizontal asymptotes, but in our course, we're going to focus on just having one horizontal asymptote at a time. Simplify it a little bit. What else? Does that function have to have a horizontal asymptote? Absolutely not. Does not have to have a horizontal asymptote. And we're going to actually talk more about asymptotes as we go through this section. So what is happening to the function as x approaches plus or minus infinity? Can you clarify that? What is happening to this function as x approaches plus or minus infinity? F is approaching, what is it approaching? The horizontal asymptote y equals -2. From both directions, or in both directions, it's approaching that same horizontal asymptote. All right. So that's your introduction to limits involving infinity. So whether your limit is going to infinity or whether x is going to infinity or negative infinity. We've talked about both of those. We've reminded you of vertical asymptotes, what they are, what happens when you approach them. Horizontal asymptotes, we reminded you that they affect the outsides or the end behavior of your curve. One thing I could mention is you are allowed to cross a horizontal asymptote. It's possible because it only determines what the ends of your curve do. It doesn't really do anything to the middle of your function. Vertical asymptotes, however, you never cross and you never touch. You can get as close to a vertical as you want, but you'll never actually touch it. Alright, that's it. Good luck, study hard, and I'll see you in the next video.